Hello everyone, welcome to the CSE116 Task 1 overview by me, Josh. In this overview, we're going to be going over some background knowledge you're going to need to know for this task, and then we're going to get into the actual doc and analyze it a bit, figure out what we need to do, and clear up some confusions because, trust me, I understand this could be overwhelming, but seek help if you need it. We're here to help you. Come to my office hours if you want to come to me specifically after watching this. I'm on the schedule. You can find me. But we're just going to go over some stuff that you guys need to know, and you're going to be off to a great start after this. So, the first thing we need to talk about is the coordinate system. We need some background knowledge before we could actually start working on this task. You guys are probably used to a different coordinate system in most games, or at least maybe you're perceived as that way. Who knows? Maybe you're not. But regardless, how it works in this game is 0, 0 is actually in the top left. The origin of the world, the game world, is at the top left, basically, of your screen. The 0, 0 point here. So, if you guys aren't used to that, try to remember this because you might be getting some weird stuff happening in the game, and it might be because you're misunderstanding the y-axis basically because the x is as expected. But so yeah, that's one thing. Another thing are vectors. Vectors. Some of you guys might not be familiar with what a vector is, which is fine. I'll go over it. But yeah, you're gonna see those throughout this project. I know that they're used for location, velocity. They're not intimidating at all. It's if you're scared about it, don't worry about it. We're just gonna go over it. They're very simple. So we have here a very low quality image of the grid system. And I have here labeled the point 2, 2. So everyone here that's watching this could probably agree with me that this point is in this cell, the origin of this cell, which is right here, which is at 2, 2. So yeah, this 2 is the x component of this point, and this 2 is the y component, which again, everybody could probably tell me this already, but this is actually a vector. As we can see here, this point 2, 2 is a vector relative to the origin of the game world. So basically all that's saying is it's this arrow, which is if you want to think of it in a simple way, you're pointing from the origin to where you're standing, whatever point you're at. So this S right here, if we consider it on this point, then we're saying the vector of this point is 2 in the x direction, 2 in the y direction. You guys would just know it as a grid point or something, but it's a way to hold an x and a y value, and we call that a vector. There's stuff we could do with these vectors that are very handy with math, but for this project, you pretty much only need to think about it as a point. But yeah, here is 9, 5 represented in vector form. I mean, this is a vector, we're just not drawing the arrow, but with the arrow, here it is. You're drawing the point 9 in the x, 5 in the y. Ignore that 9. I don't know what happened there. I didn't mess that up for sure. But vectors are pretty simple for this project. So we could say the location of E is at 9, 5, or this E is at 9, 5. So we store that data in a vector where its x is 9 and its y is 5. Hopefully you all understand that. If not, I'll touch on it a little bit more later. But anyways, yeah, as I just basically said, vectors just give us a way basically to store two values, an x and a y, and that ends up being very useful for a 2D game. So we're going to go on to reading the task, and yeah, we'll start there. Okay, so here is the doc. The first thing we're going to see is the GitHub repo. If you haven't cloned that yet, you should go and clone it. Also, if you haven't read this yet, you should probably go and read it. I'm going to go over it and explain basically what you guys need to do. However, if you guys read it first, you're going to have a better understanding when I gloss over it. Just my recommendation. Okay, so first of all, you need to clone the repo. If you don't know how to do that, then I question what you're doing for task 0. But anyways, it's pretty simple. Go here, copy this link. This is the repo link, by the way. And then go here, copy this. head on over to Java. I cloned it already. But you go up here, get for version control, paste it, and clone. And then you're going to end up basically what I'm seeing right here. Now, you're probably going to open this up and be like, oh my gosh, look at all this stuff I have. I don't know what to do. I get it. It's overwhelming, but it's actually not bad at all. You don't have to like look into most of this stuff right now, at least. You only have to go to some specific places for this task. So before I even get into Java, though, I'm going to go back to the doc. So let's move on. We talked a bit already about, the origin stuff with the coordinate system. Oh, but yeah, one thing that I should have touched on was that we've been displaying them as like ints, basically like 2295. However, they are actually doubles. So, like this right here explains that the player is roughly at 1.51 with the dimensions 1 1, which dimensions is also a vector. Just any like two values, an x and a y. Like 1 1 for this player would, if you could see my cursor, it'd be like this 1 1. That's the dimensions of the player's hitbox. So, yeah, anyways, we're going to move on to the specifications and the implementation methods that you guys have to implement and just everything basically that you guys have to do. So, we read that in the physics engine class, we have to implement the update object method. If we head into Java, we're going to notice, like I showed you before, a whole bunch of stuff here. You might see this screen. Where you need to head is you need to open this folder. You're going to want to go into source, open app. And before we even do anything else, we need to explain how you could run this game and some settings you could change. So first of all, you'll see the start game file. If you open this up here, you don't really need to read any of this, but, or at least right now, but if you run it, you should be able to run it. You're going to see the game. So this is really awesome already and cool. But if you are to press WASD or your arrow keys, you're going to notice you can't move. You can't do really anything. You could press space. Oh, you can't even do that, actually. Yeah, you can't do anything in this game right now. You could just like spin around, which isn't a very fun game. So that is why we're taking this class. We're going to make this game and add a lot of features to it and make it an actual playable thing. So, and that's going to be really fun, of course. It's actually awesome. So we specify in the doc that we have to go into the physics engine class and implement the update object method. Also, this is a very important note. All methods are public and non-static unless otherwise noted from this point forward in the course. So remember that when you make a method, I know you're used to seeing a lot of static stuff right now. You're going to make all your methods public and non-static. So we're going to find physics engine, which I believe it's in game engine, and then model physics engine. Now, again, I know like there's so much stuff here. You don't have to open it. You could ignore like you could pretty much ignore anything that we're not explicitly telling you to use right now because it's just not relevant to the task until we state so. But if we go to physics engine, again, it's going to be in app, game engine, model, physics engine, this class. This class is what we have to implement our methods in. And as we can see, we have some nice to-do comments here. And the first method, like I said before, is update object, which states that we have to update location based on velocity. And I'm not going to do it, of course, but we're going to explain it a little bit. So, if we're reading the doc here in the physics engine class, complete the method called update object that takes in a dynamic game object and a double representing the change in time. This method should update the location vector of the dynamic game object based on the value of its velocity. So that could be a mouthful, but all this information is actually available to us right here inside this method, and we don't have to do too much to get it. So you guys at this point have learned about classes and objects. And we see here dynamic game object is a class, and we're given a reference to one in the parameter of this method, which is named dynamic object conveniently. So One tip that I like to tell students, especially like in office hours, whenever you see like an object or like a class, like, and you have a reference to something and you don't know anything about like what it does or what you could do with it, if you type the name of this object and then press dot, you're going to see like all of the methods that are available to you from um, whatever object this is. And there's a lot of useful ones here, and we're going to notice some such as get location, which, if we remember, is a vector 2D. Now, we're going to explore a little bit of these just to demonstrate, first of all, how you could explore it to understand more about it, and how we could get started on implementing. So, first, for a dynamic game object, whenever you're curious about something, like what this class is or what it's doing, if you just want to read it, you can. You totally can. Um, and there's an easy way to do it. You don't have to go and look for a dynamic game object, which it's right here, and you could just do that. But I want to show you a cool way to do it. On Windows, if you hold down Control and hover over a class, you're going to see that you could click into it. I think on Mac it's Command. I don't know. I don't really use Mac. Anyways, you click on this, and we hop into the dynamic game object class, which is an abstract class. If you guys haven't learned that, you'll get to it. But we don't really care about that right now. What we do care about is that we get a whole bunch of information here, which we actually see we're going to implement some stuff in here. But I'm just hopping in here to show you guys that there's these methods such as get orientation, get velocity. Also, um, I know you guys might have not learned too much about inheritance yet, but if we look at dynamic game object up here, we see that it extends game object. Meaning that this dynamic game object is a game object and also has public methods and it has state that's available inside of game object. So if we're curious, like, okay, so I see that this is a dynamic game object. I have all of these methods available to me. I wonder what I also have that's available in game object. If we click on that, we see a whole bunch more methods that we have, but one that matters to us is get location, which is a vector 2D, and it returns the location of this game object, which is very convenient for the method we have to implement. One last thing, I'm going to jump into vector 2D and just show what it is. Like I explained earlier, a vector 2D is simply a double or two doubles, an X and a Y. That's all it is in our interpretation right now. It stores those two primitive types as data for us, two doubles, and it's very, very useful. So if we go into physics engine, um, again, if we type dynamic game object dot get location, that's available to us. And what's neat about get location is that it returns a reference to dynamic game objects vector 2D that represents its location. So what's significant about that is that if we were to assign this to a variable, vector 2D loc equals this, we now have stored a reference to dynamic game objects location, which is a vector 2D, meaning that if we wanted to change it, we could use the methods available in a vector 2D, like set x, set y, get x, get y. If we wanted to view the location, we could use dot get x, and that would give us the x component of the location vector of a dynamic game object. Or we could do dot set, which this would change the location of this dynamic game object. Now, this is not right, but if you just want to see this kind of in action, I'm going to set my location to 5.0 in the X direction, just straight up bluntly, and I'm going to go to start game. Also, if you didn't know, if you just hover over start game here, right click, you could click on run so you don't have to always exit out of the file you're working on. But I'm going to run start game. And you can see that I spawned 5 units to the right because I changed my the X component of the player's vector. So very neat stuff. You still can't do anything, and this is obviously not the way to implement that. But it's just to show you guys what how you could change a vector, because these vectors are stored as state of these dynamic game objects and game objects, and you guys can modify them just by having a reference to them. Now, I won't get into the exact implementation of the update object method because I'll leave that to you, but I will explain a bit on how the math works. So basically, we're given in update object, like I've shown you, we're giving a location, and we're able to get the location and the velocity by accessing the public methods inside of dynamic game object. We have dot get location, dot get velocity, which both will return us a vector 2 that have an x and a y component. Okay, and if we remember, location, the vector 2 just explains like where we are in coordinates, on the grid. So let's say location returned to us this vector, which was 0, 0, or the 0, 0 location. And we checked our velocity and we were at 1x and 0y. And our delta time, or our change in time, is 1. So with that information, we know that we are moving 1 unit in the positive x direction, 0 units in the y direction, in any y direction, and our change in time is 1. And we know that to get the distance that we want to travel, we have to multiply the change in time by velocity. So the distance we want to travel will be denoted by the velocity vector, which, as I just said, the x component is 1 and the y component is 0. So we're going to be moving 1 unit in the positive x direction. This will be our velocity, which this right here is 1. We're just going to call it 1 unit. And we multiply that by our change in time. So this vector right here, which is 1 unit in the x and 0 in the y, we will multiply by our delta time. So we apply that here, and because it's just 1, it's going to stay the same, but I'll draw a little bit of a change. So now this is our distance, okay? So velocity times velocities x and y times delta time is going to be our distance. So this is going to be equal to, I'll use a different color, this. And to make it more clear, we multiplied 1 into here. So that's our distance, and we're saying that this point is our location right here. And we want to move according to this distance. So with this vector, we could actually directly see where we're going to move by applying this exact vector to our location. So visually, we would move this vector 1 unit in the positive x direction because that was our distance. It's 1.0, 0.0, and our new location is going to be 1.0, 0.0, not because it's equal to distance, actually explicitly not because it's equal to distance, but because we moved that distance and applied it to our old location. So this is our new location, and it's based off of the distance that we moved. Now, this was a simple example. Let's move on to something a little with some different numbers. Our location now is 5, 4. 5 in the x, 4 in the y. So our velocity is now 3 in the positive y direction, which is down. And our change in time is 2. So if we remember what we just did, we'll make our velocity equal to, we'll call this 3 units in the, in the y direction. And we're going to call this 3. But if we remember, we have to multiply that by our change in time to get our distance. So if we draw that out here, it's going to be another one of those because 3 times 2 in the positive y direction is 6. So this is also going to be 3. So our distance ends up being, our distance vector, this whole thing right here, is going to be equal to 0.0 in the x, 6.0 in the y. So this is our distance vector. That's how much we want to move down or up in the positive y direction, whatever you want to say it. Now, if this is our location, 5, 4, again, same thing as before, where we had this vector here and we moved it, we want to apply this vector to our location. So we bring this down, and we're going to call this, these are 6 units down. And this vector is 0, 0.0, 6.0. However, our new location is not this. It was in this example because we started at 0, 0. But in this example, our new location is not 0, 6. It is 5.0, 10.0. Because we added this vector onto our old location, creating a new location. Now, if you guys implement this correctly, then you'll notice that when you launch your game up again, you will be able to move around. Now I don't have, you're still gonna not be able to, run into these walls and like, you're not doing like a lot of expected behavior, but you can move, which is cool and fun, and you should definitely, write this method the best you can and have fun playing with it, try it out. But yeah, this is the basic example for velocity. Okay, moving on to the next bullet points of implementation. The dynamic game object class. We're going to modify some stuff in this class and make it better and awesomer. So, dynamic game object. We need to modify the constructor to initialize instance variables for the following. And then we go and explain the following. But before I talk about the following, I want to talk about instance variables really quick. You guys learn these in class. We see some instance variables here like velocity is an instance variable. In fact, that is the only instance variable I can see in dynamic game object right now. So we have a little parameter here, protected, vector 2D, velocity. That's an instance variable. We got to make more of those. If we go to the task, we see that we need to make an int representing the max HP of the object, which is set to the value of the parameter, an int representing the current HP, and a vector 2D representing the orientation the object is facing. And it should be initialized to 0, 0.0 in the x and 1.0 in the y. So, and then you have to make some getters and setters, which are methods. And if you guys are confused about some of those, you could already see some that are implemented. We have get HP, get max HP. In fact, the header's already written for you, but they don't return the right thing. Now, if you're confused about like this constructor here because these braces aren't folded out in the way you're used to, that's that. Don't worry about super. But basically, in here is where you're going to type your initialization of these variables. Now, we would realize that we don't have a max HP in dynamic game object. You might be thinking, how am I going to set max HP if I don't have it? That's the thing. You got to make it. So, just like velocity, not just like velocity because, an int is not a vector 2D, but we're going to make variables up here. In fact, I'm sure we could see some in game object. Yeah, we see like a double, private double, timed animation state. Don't worry about this. You don't have to do anything with it. But I'm just showing you. This is an instance variable of game object, and it's a double initialized to 0, 0.0. And yeah, so basically that's what you're going to want to do. You're going to make your instance variables up here, set their default value in the constructor right here. We're given max HP, as we can see right here. And we're going to want to make another vector 2D as well for orientation. And that should look just like this. Don't overthink it. If we want our velocity, we want it the same way as an orientation. Our getter for velocity just returns this dot velocity, which is a vector 2D. That's right up here. Get orientation should return an orientation that should be in the state of our dynamic game object and not return this random new vector 2D because that's not what we're going to initialize in our dynamic game object. But we're going to want to initialize all of our state in our constructor. And then lastly, what we have to do here is implement a method named takeDamage that takes an int parameter, you put that in the parameter, and returns void. And this method should subtract the current HP by the amount specified in the parameter. Don't worry about negative numbers. If you guys are confused about making a method, you could just look right here. Like revive it's an override method, but it's a void method. It doesn't take any parameters in it, But you guys have seen methods with parameters like this constructor. Takes a vector 2D and an int max HP. You're going to want to create your own method here. So if I were to write public something, I'm not going to write the full header, but you're going to write, public void take damage. You're going to make your variables, and then you're going to implement the method. So don't feel like you're in the wrong place if you're like, but I have to make my own method. It's not given to me. Because you do. You do have to make your own method. Okay, so the next method you guys need to implement is back in physics engine, and it is detect collision. And detect collision will return true if the two hitboxes that it takes in as a parameter are colliding or overlapping, and false otherwise. Two hitboxes are overlapping if any portion of the boxes overlap. So, I'm going to display an example here where we see these two boxes, A and B, and we're going to say that these are overlapping. Like with our brains, we could say, oh, they're overlapping because, we could tell that this one right here is on top of B is on top of A. So we could, if we examine these points though, we notice that oh, first of all, the A's location is this point up here. B's location is this point up here. To get any of these other points, we'd have to add the dimensions of A to the location. So adding the dimensions of A to its location would give us 1, 1, which if we add both of the components of the dimensions, which will give us this point. If we just add the X dimension, we'll get this point. The Y dimension, we'd get this point. And same thing for B. So you get all the points here, and if you guys are confused about how you might code detecting how A or B are overlapping, it might be easier to think of it in a sense of when are they not overlapping? So if we look at these boxes here and we denote the middle one as A, we could point out some attributes about these of why they're not overlapping with A. For example, this box up here, which I'll call B0, is not overlapping with A because it can't. All of its Y positions, we call this Y1 and Y2, are above A's Y positions, A's Y1 and Y2. So, and better yet, if B's Y1 is greater than A's Y2, then there is no way that it could be overlapping because we know that their Y's are parallel. And we could say pretty much the same things about A, or if we look at one of these ones to the side, like we call it B1, and we say this is, X1, X2, X1, X2. We know that if these two if A's X2 is less than B's X1, then it cannot be overlapping because they're going to be parallel, as we could see here. And so if we think of it in a sense where when are they not overlapping, you might be able to create better logic in your method, which I'll show you is right here, detect collision. Okay, we're going to talk about the wall class now. Wall class, we implement one singular method called collide with dynamic object. And this one's a big one to discuss because first of all, let's go and find wall, which we're going to find it so we find it in Java app games common objects wall. Remember, there's a lot of stuff here. Sometimes you might have to search for the stuff that you need to get, but it's not too complicated. Like you don't actually have to modify a lot of this stuff yet. So don't feel overwhelmed. Because if we see here, this is the last method we have to implement for, our implementation. But we have to write a method called collide with dynamic object that takes in a reference to a dynamic game object and returns void. So we're going to write our definition for the method right here. So public whatever void collide with dynamic game object. Is it capitalized? Remember, hey, you just saw what I did right there. Is it capitalized? I don't know. I have to look at the doc because if it's wrong, I'm going to get 0 points on AutoLab because they can't recognize a method. And actually, it's not game object. It's just object. So I made a mistake. Make sure you read the doc exactly. I'm not going to implement this method, but when we say a method takes in a dynamic game object, takes in a reference to a dynamic game object, returns void, that means that we are declaring a dynamic game object. That's the type of this variable that's in our parameter. And I'm just going to call it dynamic game object. And so that's what that means. it returns void, and it takes in a dynamic game object. When writing this method, do not worry about the orientation of the dynamic game object. It doesn't matter what direction it's facing. Our tests don't like check for that or anything. Don't worry about that. Also, assume that this method gets called when the collision happens. So don't worry about like having to call this method somewhere or something like that. Just assume this method gets called when the collision happens. So those are the two main big points that you have to remember for this. Um, but yeah, so the premise of this is whatever direction you're the shortest distance away from not colliding with this wall anymore is the direction that you're going to want to move. So basically, I have a little example up here, I believe. Yeah, just so like if you know you're colliding basically on this side of the wall, and it's like blatantly like you're the closest way to get out would be escaping in the positive x direction. That's the way you're gonna want to move. So whatever way is the shortest way. So you only have to check four directions. You have a positive x, negative y, a positive y. You don't have to worry about moving like a some sort of combination of these, like this arrow here. Don't worry about that. You just have to pick one of these four. Whichever way is the shortest of these four is the way you got to move. But that's the premise of this method, so shouldn't be too bad. Okay, so the last thing I'm going to talk about is testing, and more specifically, the testing utilities. We're writing testing utilities to help you guys. Like, if you guys write these, you're going to have an easier time writing tests. Testing utilities are meant to speed up your testing process. They speed check basically some attributes about this project and confirm that they're working correctly. So, for example, this testing utility here, we're comparing players. Write a method, compare players, that takes reference to two player objects as parameters, returns void, and make sure that those player objects contain all the same instance variable values, location, velocity, orientation. And keep in mind to check like velocity. You don't compare their references. You don't compare player one's velocity reference to player two's velocity reference. You compare their x and y's because their references are going to be different. They're pointing to different objects on the heap, but they're probably not. They're probably not in, or they could be. That's what you're checking. If they have the same x and y components. So so in Java here we have our test. Do not change these tests. You don't have to write tests for your wall collision thing if you run these, which you could just do by doing this. Right click on that, and I know you might not be able to see that, but I'm just right clicking on the class name and clicking run, and I'm getting errors because this isn't implemented yet. But you're going to write your testing utilities in this class, and this testing utility, I believe it's called compare players. Yeah. So you'd start writing that here. I'm going to start you off compare players. So I'm going to take a player one, and player two. And so that's all it is. It's not a test annotation or anything. Okay, yeah. So we have this compare players method, and you are not annotating it with an at test because it's not a test on its own. It's a utility. And we use this utility to expedite the process, like I said. So remember, to get attributes about a player, you could do player one dot, for example, get location. If you're comparing the location, you want to check if it's x location dot, or sorry, if it's vector two, which is get location of player one. This is a vector two. Um, you don't want to compare that to the reference of player two's location because they're, like I said, they're going to be different. But you could get its x value and compare it to player two's x value. And when I say compare it to, what do I mean? I mean using assertments. JUnit provides a lot of assert methods that we could use to check if two things are equal. One that you'll probably want to use here is assert equals. So an example would be player one dot get location dot get x, and we want to compare that to player two dot get location dot get x. And here we're basically saying assert that it's true that the x location of player one is equal to the x location of player two. Simple as that. But you're going to have to do everything as specified in the doc. It's way more than just this. But you might be wondering, well, where do I use this testing utility? Well, you're gonna write your own tests. So if I write a test and just say like um, test um, test maybe compare players. Horrible name. Do not name it like this. But if I wrote a test like that, um, oh boy, that's the annotation. Public play. Um, for a test like this, I could call compare players, and I don't need to write any assertments because it's already asserting equals here. But then I'd pass in, two players. I'm gonna just pass in nulls for now. But you would create two player objects, for example, like player p1 equals new player, and you have to give stuff to its constructor, which is a location. So you do a new vector2 for a location, maybe like it if we want to set it 1 1 here, and then what's the other one? Max HP maybe 10. Who knows? And now we could pass this player into the first parameter of our compare players. I'm not going to do any more of this, but you can make another player and compare that your thing is correct. Maybe you want to hard set some values of a player. The testing utility is supposed to help you speed up the process, test things quicker. You should write them for sure. But other than that, you have to write some tests. You don't have to write any tests for the wall, collide with dynamic game object. Those ones as shown here, they're given to you. But write your tests for physics engine, and the same way that I just showed, you'll write a method here at test annotation, and you're going to use assertments. If you get confused, take a look at these examples here, just at how it does it, like with an assertment and like two doubles with the epsilon. Um, just follow kind of this format of testing. It's pretty easy to tell from the given tests. But if you read these docs, you could see that like dynamic game objects can't be instantiated directly. So yeah, don't worry about some of this stuff. To create a player object, so that's X and Y location, like I just did, and call update object. The doc is very explicit. Follow the doc. Um, but yeah, and that's pretty much it, guys. If you do have questions, ask on Piazza. Come to office hours. We have a ton of TAs that will help you. But also, before any of that, really give it a try. Like, really stretch your brain on some of these problems. Like, read the slides. And like I said, ask us questions if you need to. So, yeah, that is it. And good luck.